Hello, everyone. Today we are about to start with chapter 7.5, that is dealing with the inverse trigonometric functions. Now, the first thing is, if you all remember from college algebra, now when we start working on the inverse function, it is quite similar to those inverse functions. Like if we have, let's say, we were having, I'm just writing one quotient and see if you can figure out what we are trying to do in that. If it is y equals x plus 3, and we used to write it in the form y minus 3 equals x, and then we interchange x and y, and we write x minus 3 equals y, or we say y equals x minus 3 is the inverse function. So today we are dealing with the inverse function of inverse trigonometric functions, like inverse of sine, inverse of cosine, and inverse of other trigonometric functions. All right. Now we start with the inverse of sine. We start with inverse of sine. Number one, first thing we have to check that the function is 1 to 1. Now, if you remember, initially we started with the horizontal line test. All right, I'll just give you the overview of both. Initially we started with, let me see. Yes, initially we started with the vertical line test. Vertical line test says if it is a function or not. Vertical line test says if it is a function or not. And the second thing was horizontal line test. Horizontal line test will prove 1, 1. Now, what do we mean by this 1, 1? This 1, 1 means that for every value of x, there is one value of y. Like x and y are associated. One x is associated with one y. Now, if you look at this diagram here, the vertical line test, it passes the vertical line test. Any line draw anywhere that will touch at one point, the vertical line. But if we look at the horizontal line test in this case, okay, let me erase this. Now they have drawn one horizontal line, this blue line. Now this blue line is touching at more than 1 points. 1, 2, 3, 4, 5, and 6. So it fails the horizontal line test. Right now, this function fails the horizontal line test. That means this function or this graph is not 1 to 1. So what we do in that case, to make this function 1 to 1, we just consider the interval. What interval we picked? We picked the graph between -90 to +90 only. All right, now this is the graph. Let me erase this stuff here. Now we pick up the graph from -90 to +90, this much, this part only. Now if we look at -90 to +90, if I draw a vertical line over here, it passes the vertical line test everywhere. All right, and if I draw a horizontal line, it passes the horizontal line also. So the reason I just pick up this portion is I just want that this graph should pass the horizontal line and the vertical line test both. The vertical line test will make it a function. Vertical line test make it a function. And the horizontal line test will make it 1, 1. So I just want both. I want it to pass the vertical line test as well as the horizontal line test. We are just dealing with the sine function right now. Okay. Now, so from -90 to +90, the inverse will exist. The inverse will exist. Okay. Now let's find the inverse of the sine function. How to find the inverse? Now, since we are dealing with this -90 to 90, First thing is proved that the function is 1, 1. Second, we use the 5-step rule. I hope you remember that 5-step rule. Let me go back. Let me go. Okay, so first thing is from negative 90 to 90. We are working between negative 90 to positive 90. We write the function as y equals sine x. We write the function as y equals sine x. Now, after this, after we write y equals sine x, y equals to sine x, we solve the equation for x. That means I need x by itself. So now the thing is y equals sine x. Now how do I get x by itself? What I'll do, I'll operate by inverse of sine on both sides. I'll write sine inverse y equals sine inverse sine x. Okay, the only thing I introduce right now is on the left hand side I write sine inverse, and on the right hand side I write sine inverse. What happens here? This is sine inverse and this is sine. They are actually inverse operators, so they will cancel out each other's effect, and we are left with right hand side as x and the left hand side is what? Sine inverse y. So this is what we have in the third step. Sine inverse y equals to x. And in the last step, if you remember from your college algebra, what we do, we just interchange the value of x and y. So when I interchange it, I will write it as y equals sine inverse x. That is the inverse function. That is the inverse function. And the second thing, now I'll directly go to the application. What is the application or what we need? This was just the explanation, what we need. Now, everything that is written here is the important stuff. Now, over here, we see that this chart is very important, or this table. The inverse sine function is defined as y equals sine inverse x if and only if x equals to sine y with the domain and range. All right. Now let me write it down because it is a bit confusing. Okay, so if we have initially what we were using, actually the function was sine. All right, now right now what we have, y equals sine inverse x, and they say domain is what? Domain is -1 to +1, and range is -90 to +90. Now this thing is important. We need to understand what we are trying to do with these domains and range. The reason why we need this domain and range. Initially, this is inverse. This is inverse. All right. Now normally, the function was what? The normal function y equals sine x. Okay, now in this function, what happened? This was angle. So in this case, domain was what? Domain was for sine. Domain is negative or 0 to 360 was the range. oh sorry, domain, and range was -1 to +1. Domain is actually all real numbers. Domain was actually all reals. Anything can be the angle. Angle can be 0, angle can be 30, 50, 60, 360, 270, anything. Angle can be anything. Domain is actually all real numbers. But in the inverse function, what happens? This is the number. In inverse functions, x is between -1 to +1. And when I plug in x, it will give me what? It will give me an angle between 90 to -90. Sorry, -90 to +90. So in this case, we plug in the value and get the angle. Now this is the main logic that we need to understand. Okay, let me find a question based on this, and that will make it better. You will understand it better in that case. Okay, like they say, we have to find this, the inverse over here. They say evaluate sine inverse radical 3 over 2. Now again, see, the number is given. This is the value. And what I need angle. I'm looking for angle. This is what I'm looking for. I'm trying to find. Earlier, what I was doing, I will plug in angle and find the value. But not right now, it is other way around. Okay, let's see how we solve these questions. So the first thing, alpha is a sine inverse radical 3 over 2. Now, the angle in the interval -90 to +90, whose sine is radical 3 over 2. Now, if you check the mini table, radical 3 over 2 in sine radical 3 over 2 is pi over 3, and pi over 3 is actually 60 degrees. Okay, now that is the angle we are looking for. Okay, so sine alpha is radical 3 over 2. So what is the value of alpha in that case? Alpha is pi over 3, and that's it. That's the answer. Once again, on the same question, where we start from. This is inverse, all right? Let me write it the other way. So this is alpha equals sine inverse radical 3 over 2. What I do is from my side, I will operate sine on both sides. Sine alpha is sine inverse radical 3 over 2. Now this is the thing that I introduce from myself. On both sides, I introduce sine and I introduce sine. Now this sine and sine inverse, they actually cancel out each other's effect, and we are left with what? Sine alpha is radical 3 over 2. Sine alpha is radical 3 over 2. Check the mini table, radical 3 over 2. What is the alpha angle? Alpha angle is pi over 3. Now that is what I'm looking for. Alpha is pi over 3. Come on, let's try another question. Let's solve one more positive and then we'll move on to, okay, let's say this one. Now, if we have to solve this question, first thing I check is I'll just write it as alpha equals sine inverse radical 2 over 2. Okay, next step, sine alpha equals sine inverse radical 2 over 2. And sine alpha is what? is radical 2 over 2. Now sine alpha is radical 2 over 2. I'll again check the mini table. Sine, for what angle sine is radical 2 over 2? Sine is radical 2 over 2 for pi over 4. Pi over 4 or 45 degrees. So alpha is pi over 4, or I can say 45 degrees. That's the answer. That's the answer. Exactly. We just need to check which angle we are dealing with, or what stuff we are looking at, and we simply write that. Okay, let me pick up one negative angle now. Well, you all know these videos are actually uploaded on D2L as well as on YouTube. If you have subscribed to the angle, whenever a new video is uploaded, you'll get a notification that the new video is over there, and I just write each chapter's name over there and then upload a video. All right, let me pull up a negative angle. Let's work on this. All right, now in this case, in the same way, I'll write alpha equals sine inverse negative 1 over 2. So operating on with sine on both sides, sine alpha is sine inverse negative 1/2, and they actually cancel out each of those effects. So sine alpha is negative 1/2. Now sine alpha is negative. Now please make sure one thing: whenever we are dealing with this inverse, sine inverse, I said sine inverse will be from negative 90 to positive 90. That means the value has to be here. Okay, if the value is positive, it will be in the first quadrant. If the value is negative, it will be in the fourth quadrant. So 1/2, where is the value 1/2? 1/2 is at pi over 6. So I will simply write alpha is negative pi over 6, or it is what? It is 30 degrees negative. Why 30 degrees negative? Because I have to go in the fourth quadrant. In fourth quadrant, how we calculate angle? We calculate angle in the clockwise direction, and that is what? 30 degrees. So simply, it is quick and easy to go over here on this function, this inverse. If it is positive, it is in the first quadrant. If it is negative, it is in the fourth quadrant. That's it. That's all we do for inverse of sine. Okay, let me pull up another problem on this. Like if we have a question like this, it says sine of sine inverse 1 over 3. Now, if we look at this question, the first thing you have to check is whether this number is between negative 1 and positive 1. Yes, this number is between positive 1 and negative 1. This is defined. So sine and sine inverse, they will cancel out the effect, and the answer is 1 over 3 directly. No need to do anything else. Sine and sine inverse, they cancel out the effect, and we get the answer as 1 over 3. Now there can be a question, there can be a tricky question like sine of sine inverse 2. Now this thing is not defined. Not defined.
Is it not defined because it's not between the two amounts?
Yeah, it is not between negative 1 and positive 1. Make sense?
Yes, sir.
This 2 is greater than this number should always be between -1 and +1. All right. If it is greater than 1 or it is less than -1, the function is not defined. All right. In this case, we directly say that this is not defined. Simply, if you get something that is less than 1 or greater than -1, the function is defined. Like, let me check another example if they have any question like that. Well, this one is also defined directly. It is 1/7, 1/8, 1/5. All these functions are defined actually. Okay, let me find if I can see any function that is not defined. Okay, now this is the other way around. This is using, now in this case, sine inverse is outside and sine is inside. Now first, we are looking for sine 3π/2. Now if you remember, this is π/2, this is pi, and this is 3π/2. At this point, sine is -1. So we have what? Sine inverse -1. Okay, now -1 is this value here. Now, I know, now I'm calculating sine inverse of sine. Now, if we are calculating inverse for a positive number, it is in the first quadrant. If we are calculating for a negative number, it is in the fourth quadrant, because we always say inverse of sine is between what? -90 to +90. Now, if you look at this number here, -1, -1 is over here. So your final answer will be -90. That's it. You directly get the answer. The answer is -90. I'll just write another question. One, two, three, four. Well, these are actually same. All are going to the same point. Like, let's say if we have, I'm not solving this question actually. Let's say if we have, let me write another question, like sine inverse sine, let's say 5π/2. Now, first thing is sine 5π/2. Now, if you check 5π/2, what is 5π/2? This is π/2, pi, 3π/2, 4π, oh sorry, 2π and 5π/2. 5π/2 is again 90 degrees. And 90 degrees, what is the value of sine? Sine is 1. So I'm calculating what? Sine inverse of this value is 1. And sine inverse 1 is what? Sine inverse 1 is 90. Sine inverse 1 means angle is positive. And where is the value of sine as 1? Sine is 1 at 90 degrees. So it is actually both ways. Once we have to use the table, the mini table directly, and second time we have to use the mini table inversely. So we are actually working in both the directions. Okay, now there will be some questions. Okay, let's check if we have a question like this. They say if sine u is x/3, express the following expression in terms of x. Sine u plus cosine u. Now the question seems to be difficult, but once we look at the solution, again, we are dealing with sine u. Angle is u, and it is x over 3. What I'll do, I'll try to draw a triangle over here. How? Now, if we look at sine u equals x over 3, I draw a triangle. So if you look at a triangle, in your triangle, if this is the angle, x over 3, x is opposite, 3 is hypotenuse. So x is opposite, 3 is hypotenuse. Using the Pythagorean theorem, I calculate the third side. Third side is radical 9 minus x squared. This is how they use the Pythagorean theorem. 3 squared equals to x squared plus y squared. They consider this as y initially. X squared plus y squared equals 3 squared. So what I need is I need to find the value of y. So I just keep y on one side. Y is 9 minus x squared. Y equals 9 minus x squared and square root of that. Now, once we are here, we got all three sides. All right. Now, final step is I'll just write sine u plus cosine u. Sine u plus cosine u equals what? Sine u is given x over 3. Cosine u from this diagram. From this diagram, cosine u will be adjacent over hypotenuse. That is radical 9 minus x squared divided by 3. That's it. That's the answer. Radical 9 minus x squared divided by 3. And that's the answer. That's what we're looking for. Now, what I have done, the way they said, express this how? In terms of x. I have expressed sine u plus cosine u in terms of x. Again, what we are doing, we are actually using the concept of Pythagorean theorem, and we draw a triangle from the given notation, and then we simplify. Come on, let's check another problem on this. These questions are quite similar, and you will see any such question on your exam. Like, let's work on this one. Again, what I do is I draw a triangle, right triangle, and we consider this angle as u. Sine u is x over 5. So this side is x, this side is 5. Using Pythagorean theorem, if I consider this bottom side as y, what I'll say x squared. I will say x squared plus y squared equals 5 squared. That means x squared plus y squared equals 25. And that means y squared equals to 25 minus x squared, or y equals radical 25 minus x squared. Okay, now we are ready to write this. This thing is what? Sine u, x over 5 plus cosine u. Cosine is adjacent over hypotenuse. This is adjacent. Radical 25 minus x squared over 5. That's the answer. We have expressed that expression in terms of x. Sine u and cosine u in terms of x. Now, on the same way, they can ask you to express in terms of x sine 2u. Now, what is sine 2u actually? Sine 2u, if you remember those double angle formulas, sine 2u is 2 sine u cosine u. 2 sine u cosine u. Now sine u is given. We actually calculated cosine u, cosine from here. We actually calculated cosine u. We multiply sine and cosine and multiply by 2. From here we can get sine 2u. Now the thing is, you have all the formulas. The only thing is how to use them. That is the only important part right now. How to use those formulas. Okay, now the inverse of cosine and tangent, they are a little bit different from sine. The only thing that differs is actually the domain and the range. That is the only thing different. Now, if we look at cosine, I'll just give you a brief idea about cosine. Now, this was a cosine curve. Again, you see it fails the horizontal line test. The horizontal line is touching at 2 points. It fails the horizontal line test. So we do not consider the whole function. We just consider from 0 to pi. Now it passes the horizontal line test. 0 to pi, it passes the horizontal line test. Now everything remains the same other than what happened over there for sine. If I say sine, sine was in first and the fourth quadrant because it was from negative 90 to positive 90. But right now we are dealing with cosine. Cosine is from 0 to pi. That means, let me change the color for cosine. Cosine is from 0 to pi. That means cosine is in the first quadrant, the inverse of cosine, sorry. The inverse of cosine is in the first quadrant or in the second quadrant. Please be very careful. Do not confuse these sine and inverse of sine, cosine and inverse of cosine, because you all have been using that sine is positive in first and second. Agreed. Sine is positive in first and second, but now we are dealing with inverse of sine. It's a different thing. Same way, inverse of cosine, if it is positive, it is in first quadrant. If cosine inverse is negative, it will be in the second quadrant. This is the only thing we need to understand. Again, it has to be between 1 and negative 1. Okay, let me pull up a question and you will understand it better over there. Like, see this one here. Again, they're asking about cosine inverse of 1/2. Now, first thing, 1/2, when I look at 1/2, I'll just write it as alpha equals cosine inverse 1/2. Okay, now I'm calculating cosine inverse. What I do is I operate cosine on both sides. They cancel out the effect. Cosine alpha is 1/2. I check the mini table. Cosine 1/2, oh, it goes to the different side. Cosine 1/2 is at pi over 3. So alpha is pi over 3, or I will say it is 60 degrees. That's it. But what happens if the angle is negative? Let me say if the angle is, let's solve a similar problem. Let's say we are solving cosine inverse negative 1/2. So alpha equals cosine inverse negative 1/2. Okay, let me write it down. So I operate cosine on both sides. Cosine alpha is cosine inverse negative 1/2. They cancel out the effect. So cosine alpha is negative 1/2. Now, if cosine alpha is negative 1/2, please be very careful over here. I said if cosine alpha, we are calculating for a negative angle, that means it is where it is in the second quadrant. Now, how to take that angle in the second quadrant? Pi over 3. Now, pi over 3 becomes a reference angle. So it will be what? It will be 180, or let's use pi. Pi minus pi over 3, that is actually 2 pi over 3. Alpha is 2 pi over 3 or I will say alpha is 120 degrees. This thing is important. Once again, I'm repeating, how do I get this angle? Now, as I said, cosine alpha is a negative 1/2. I'm calculating inverse. Inverse positive is in the first quadrant, negative is in the second quadrant. I'm calculating for negative 1/2. Now, if I ignore the sign and this 1/2 actually tell me about the reference angle. 1/2 tell me about the reference angle. Now, if I look at the reference angle, what is the reference angle in this case? 1/2. For 1/2 in cosine, reference angle is what? Pi over 3. Now, this pi over 3 is in the second quadrant. Reference angle is always with the x-axis. Okay, so what I do is I check it as pi minus the reference angle, and if I do my math, what I do is I multiply by 3 at the top and divide by 3. We have a common denominator. 3 pi minus pi gives you 2 pi, and that's the answer. Okay, so this is how it works in the negative angle. For the negative angle, this is how everything is worked out in the negative angle. It will go in the second quadrant. Now, there can be questions like this. Again, we can evaluate this easily. Cosine inverse 2 over 3. Now, first I will check 2 over 3 using a calculator, and then I will calculate sine. Or there is another way to solve this question. We can solve this question using a triangle. We got all three sides initially. So I consider this as theta as cosine inverse 2 over 3. So finally what I need is actually I am looking for sine of theta. What is sine of theta in this case? Radical 5 over 3, and that's the answer. Radical 5 over 3. Why I'm writing 3 over 3? Radical 5 over 3. Okay, now if we log, okay, now we were on this screen. Okay, now if we look at this question here, I'm just trying to explain the question again. We started from here at this point. Cosine inverse is 2 over 3. From here, I consider this whole thing as theta. This whole thing as theta. Now, if this whole thing is theta, theta equals to cosine inverse 2 over 3. I operate with cosine on both sides. Cosine goes to the other side, and this becomes cosine theta is 2 over 3. Use the Pythagorean theorem to get this opposite side. Now, what I need is, since this whole thing is theta, I just need sine theta. And sine theta is what? Sine is opposite over hypotenuse. That is radical 5 over 3. That's the answer. Straight away, you get the answer for these questions. Now, if during exam, you do not figure out the right answer, what you do is you just use your calculator. If you're using a scientific calculator, it will directly give you the answer. It will not be like this because you all know if we are using a scientific calculator, it will show you something like now radical 5. If you calculate radical 5, let me show you. So if we write 5, radical will be 2.236. So you answer, if you are using a calculator, 2.236 divided by 3. It will be actually 0.7454. This will be the answer if you use a calculator. Now the only thing you have to do is you have to plug in the answer choices and see if your answer, any of the answer match this. So there are different ways. If you want to use a calculator, it's good enough. If you want to use this traditional method of drawing a triangle and then trying to calculate a value, you can do that also. Okay. So right now, well, I consider this is the best time to learn more skills. I know trig is not easy, but this is the right time to work more and more on trig and get some more good scores. Okay. Now, the third and the last thing that I need to discuss today is regarding our tangent, how we find inverse tangent. Now, tangent is actually 1, between negative 90 and positive 90. So again, the function is from negative 90 to positive 90. This is the range. Our answer will be from negative 90 to positive 90, and the domain is negative infinity to positive infinity. Now, please make sure whenever you're working on this, please make sure that when we are dealing with inverse functions, make sure sine inverse, tangent inverse, or cosine inverse, and tangent inverse. Now these are over here in the first quadrant, positives, the positive values. Negative value of sine inverse and negative value of tangent inverse is here in the fourth quadrant, and negative value of cosine inverse, if you're trying to calculate, that will be in the second quadrant. Now this is the only key point we need to know in this this question, this topic. That's the only thing we understand in this topic. That positives, all three are in the first quadrant, negative, sine and tangent are in the fourth, and cosine is in the second quadrant. We do not use the third quadrant in this case. Okay, same way, if we look at the questions based on tangent, simply if we check this, tangent inverse 1. So what I'll say alpha equals tangent inverse 1. All right, I'll operate tangent on both sides. Tangent alpha is a tangent of tangent inverse 1. They neutralize the effect, tangent and tangent inverse. So tangent alpha is what? 1. And looking at the mini table, if I check the mini table, tangent alpha is 1. For what angle tangent is 1? Tangent is 1 for pi over 4. So alpha is what? Pi over 4, or I will say alpha is 45 degrees. Same way, let me write another question with a negative. Let's say we have to find tangent inverse, let's say radical 3. Okay, let's say negative radical 3. So alpha is tangent inverse negative radical 3. So what I'll do, I'll operate tangent on both sides. Tangent alpha is tangent inverse negative radical 3. These two neutralize. It gives me tangent alpha is what? Negative radical 3. Now first thing I check where tangent is radical 3. Ignore the sign. First check where it is radical 3. Radical 3 is at what angle? Pi over 3. Now tangent alpha is negative. Which quadrant? It is in the fourth quadrant. In fourth quadrant, I'll simply write it as negative pi over 3 or negative 60 degrees. That's the answer. Negative pi over 3 or negative 60 degrees. Okay, now we may have questions like this. Cosine of tangent inverse 2. Again, we have to do with the same stuff. We start with the tangent inverse 2. We draw a triangle from there. Now, if I consider tangent inverse 2 as angle theta, if I consider this thing as angle theta, theta is tangent inverse 2, and when I bring tangent to the other side, tangent theta is 2. 2 over 1. Tangent is 2 over 1 means it is opposite over adjacent. I draw a triangle on, consider this angle as theta, this is 90, opposite is 2, adjacent is 1. Using Pythagorean theorem, 2 squared is 4, 1 squared is 1, 4 plus 1 gives you 5. This side is radical 5. Now, if we have this thing, we have the triangle. Now, since I called this as theta, what I'm trying to calculate actually, I'm just trying to calculate cosine of theta. Cosine of theta is what? Adjacent over hypotenuse. Adjacent over hypotenuse gives me, that's it, that's the answer. On these questions, again, they have given us tangent u. Tangent u is 2x over 3 to express sine u, cosine u minus u. Now we have tangent u and we have to express everything in terms of x. All right. Again, they have given you the format how we write the answer. Now again, tangent u 2x over 3. Again, I will draw a triangle, right triangle. I will say this is u. Tangent is what? 2x over 3. 2x over 3 means opposite is 2x. And adjacent is 3. When I use a Pythagorean theorem, 2x squared will be 4x squared plus 9. This will be the hypotenuse using Pythagorean theorem. Now this is the main thing. Only using a Pythagorean theorem in this question is important. Now once we have used a Pythagorean theorem, what I need to calculate this. Sine u plus cosine u plus, sorry, minus u. Minus u. Okay. Sine u. Sine is opposite over hypotenuse. 2x over radical 4x squared plus 9 plus cosine u, adjacent over hypotenuse, 3 over radical 4x squared plus 9 minus u. How do we calculate u? Now to calculate u, this is actually what? Tangent u. Let me write it down here. To calculate u, what we do is we operate with the tangent inverse on both sides. So this will give you what? This will give you your statement. Statement gives you tangent inverse tangent u equals tangent inverse 2x over 3. The only thing I have done is I have introduced this tangent inverse on both sides of this equation. Tangent inverse. Now tangent inverse and tangent, they neutralize the effect and we are left with u. U is what? U is tangent inverse 2x over 3, and that's the answer. Now see, the whole function, whatever they were asking, sine u plus cosine u minus u, I have expressed the complete function in terms of x. There is no other variable over there. It's just x involved. That's what they wanted. They just read the statement. They say use tangent u equals to 2x over 3 to express sine u, cosine u minus u in terms of x. We are expressing everything in terms of x. Okay, now that's what we need on this chapter, chapter 7.5. Now what I'm expecting from you all, this video will be uploaded within next 10 to 15 minutes. It will be there on